Hi there, this is Shrikant Asare. So, in this lesson, we are going to learn about the performance tuning when it comes, especially using for loops. Okay, so in this example, we take two instances of for loop to execute the sum of three individual arrays. Okay, to execute the sum of three individual arrays. Okay, so first and foremost, let me take the three arrays here. Okay, so first let me declare the three arrays. So array 1. So I'm just initializing that array with some data here, some 10, 20, and 30. So likewise, I'm taking the second array, int. So array of 2 is equal to 30, 40, and 50. Okay, it's 30, 40, and 50. And next array of 3 is equal to some 60, 70, and 80. Okay, so just taken three arrays here. So our intention is to calculate the sum of these three arrays using for loop. The first and foremost, in order to calculate the system time, we have that we have a function, method called current time in millis to store that value. Before and after, here we intend first to take a long variable here. Okay, so long t1, since milliseconds is a huge number, so we are intended to take that variable in long here. Okay, the system dot current time in millis. Okay, so NetBeans does all the work for us. It automatically pops up the name of the function within the IntelliSense here. Okay, so what happens is until this instance, this up to this instance, we have the system time, the current system time, and then following that we have some lines of code by using the for loop as we have discussed here. Okay, so first let me take the for loop here. The first we will run an outer for loop with a huge number here. Let me say 1 million times. 1 million times. Let me take a huge for loop here. 1 million times runs up to 1 million times because we are calculating. So we need to extend or prolong the process such that we get some good time to calculate in milliseconds. And within that outer loop, so we take three different loops here to calculate the sum of all the three individual arrays. The first instance, again we are taking another loop here. We are taking another loop, first loop, to calculate the first instance. The first sum the sum of the first array. So here what I'm doing is, instead of directly saying the count of the number of elements, we are just taking the length of an array and x plus plus here. Okay, so next sum plus is equal to a compound assignment operator I am using here, and array 1 of x. Okay, so we have calculated the sum of the first array, which is array 1. Okay, the same thing we are going to repeat here for a couple of times, because totally we have three different arrays here. So I have just taken that three different times, and we have simultaneously calculated the sum here three times here. Okay, simultaneously calculated the three arrays. Okay, so at the end of the point here we intended to calculate once again that what we call the system time here. Okay, so after completing the statements, the for loop statements, again we tend to calculate the system time here. So again for that we take the long variable system dot current time in millis. So what we have got here. Okay, so if you say t2 minus t1, you get the total system time completion or execution time to execute these statements here. Okay, so and then we have let us take the another next version 2 or next for loop 2. 2. Okay, so for loops 2, this let us comment the code here as for loop 1. Okay, so for loop 1. Okay, so for loop 1 and for loop 2, the next for loop, what we are going to do is instead of taking three different instances of for loops within the outer loop, we intend to take only one instance and calculate all the sums within that instance here. Okay, so there is a dramatic change of the system time in executing the number of consecutive for loops in a single for loop. So we'll see that. So first let us run the outer loop here, just for the purpose of prolonging the to get some good system time here. 1 million, just calculating, keeping prolonging it a bit, and then within the outer loop we have taking the other loop here, which is a single loop, not three loops this time. So x less than, since luckily we have the three lengths, the length of three arrays is same, we can use any instance, any array. Let us say array 1 dot length here, array 1 dot length property, and x plus plus. Okay, so within that for loop, what we're going to do is we'll calculate the sum statement with the three different times here. Okay, so array sum plus is equal to, so here we are using the same instance once again. So let me declare the sum variable, because in order to avoid the confusion here. Okay, the sum plus is equal to array 1 of x. Okay, so array 1 of x, and let us take the same statement a couple of times. Okay, so a couple of times once again, because so we're calculating the sum of three different arrays as we, so array 2 and array 3 here. Okay, so array 2 and array 3. Okay, so now let us calculate again the long t3. Let us take the system time. So up to this instance, let us say system dot current time in millis, and let us show the system. Now let us calculate the system time and the execution time for both the two different for loops here. Okay, so let us call the system dot out dot println system dot out dot println statement, and to calculate the for loop, let us say within the quotations here. Okay, for loop, just to show the difference, I am writing here for loop 1. For the for loop 1, it takes how much time it has taken. So if you say t2 minus t1, you have the total time it's taken by the system to execute for the for loop here. Okay, just a second, and then we have taking the same system.out.println statement once again here, and let me say the for loop 2. For for loop 2, let us say for loops 2, let us say t3 minus t2, I hope. Okay, so if you execute the code, you get the better idea of what we are doing here. Let me execute the code here. Okay, so it's obvious that for the for loop 1, it has taken 31 milliseconds here, and for for loop 2, it has just taken 28 milliseconds. Just a second, there must be a somewhat more difference here. I think there is a problem with the number of zeros. Hope everything is correct here. Okay, so let me run once again. So if you see here, for the for loop 1, it has taken 26 milliseconds, and for the for loop 2, it has been taking 18 milliseconds. So if you go back to the program once again, the reason because is always the for loop, the instance 2, okay, the version 2 of calculating the sum of three different arrays always will be executed much faster, a faster version. So this is the faster version when compared to this version, because here we have nested loops. So we keep on taking the three nested loops within the outer loop here, and we are doing the same thing repeatedly, and we have unnecessarily increased the number of statements, which increases the execution speed and decreases the performance. Okay, so always you need to keep in mind when you are calculating when you are calculating some of different arrays, and if you can reduce the number of lines of code, it helps better for executing the program in less using the system time very less, and therefore it enhances the performance. Okay, so here in our case, when compared to the for loop 1 version, the first version, the second version is always a faster thing. Okay, since we have reduced the number of statements, number of for loops repeatedly doing the same task here. So no matter how many times you run this code, every time the for loop 2 will always be executed much faster than the first version. Okay, so hope this small tutorial helped you. So see you in the next lesson. Goodbye.